Who did I stop at? Typing right there. Bailey, I don't think I stopped you. Did I stop you? Okay, go ahead, Bailey. Is this odd or even, please? It's an even function. So Bailey, before you're done, what does an even function sort of look like? Okay. And those of you that have your phones, you can check, confirm this on Desmos if you want to, okay, or whatever else, okay? The reason it's negative x squared this time, right, is because negative 2 is a coefficient in front, okay? Just a reminder, Cole, what does negative x squared look like? Uh-oh, like, yeah, upside down u, okay? For those there, so upside down u. So that is quadrant 3 to quadrant 4. Okay, yeah.
When you do these questions, do you have to write the quadrant 3 to quadrant 4?
No, it just, I just want to write it on there for now, no. Oh, and behavior, please. Go ahead, please. Very good. There we go. Okay, two last things I want to do, then I'm done. And I'm sorry it starts off so dry. I wish we could keep background or something to say. Okay, but let's start with graphing, right? Example. Okay. Even functions. Have line symmetry from the y-axis. My example is here. If I were to graph y equals x squared, let's do x to the fourth, how about? If you were to see this on Desmos, that would be at a perfectly symmetrical down here. And you know that if you think back to grade 10, right, that's exactly how parabola was, right? There'd be a point like that. Anything that is even will have a line in the middle there that's balanced, okay? Well, not everyone, but the ones which stay, they will, okay? That's called line symmetry symmetrical, okay? The second one is we're going to say odd functions. Odd symmetry. Are symmetrical about the point 0, 0. Y equals x cubed. Okay, if you take a look, those are symmetrical points. If you take this line right here and you rotate it like this, that's exactly the same line. Okay, so that's the symmetry that they talk about in here. Now, not all functions are symmetrical like this, but all the base ones, all power functions are that we talk about here. Okay, and we'll talk about these when we get to graphing in the next few days. And the textbooks love symmetry. All right, to finish off here, I want to talk about domain and range one more time because the textbook, and if you have Mr. Kemp next semester, who is Mr. Kemp will talk this next semester? You have him twice, do you? I'm going to tell you a little, can I tell a joke here? I'm going to tell a joke here. Sorry, I know you guys don't care about my joke at school because I do that raise the hand. Okay, and back to Mr. Kemp there. Mr. Kemp does his domain and range this way, and the textbook might, so I'll talk about one other way to do domain and range. The textbook uses brackets and stuff like that, so I want to talk about this and then we'll stop for the day. Okay, when they say the textbook will use soft, we'll use curly brackets to mean less than, less than like that. They will use square brackets to mean this. Is it good, is it bad? I don't know. But this is the type of thing, those are round brackets, so you can't put it anywhere. Okay, those are the types of notations that the textbook will use. Okay, so square bracket means less than or equal to, and a round bracket just means less than. If you don't want to use that notation, you do not have to. Mr. Kemp loves it though, and I love Mr. Kemp. So I'm actually used to a math question on it. I used to have gotten over him now, but I used to have math question on Mr. Kemp. So this is the way he does his main arrays, so just for those that are in travels with him, just so you're not totally blown away by that. The textbook also mentions it in this chapter, that's not for anything.
Was this a square bracket?
Oh, square, good question, sorry, I'm talking to myself. What a round bracket means is just less than, and a square bracket means less than or equal to. So that's a distinguishing characteristic. If you want to write x as anything, you've got to go infinity to infinity. If you want x is in the middle of 3 and infinity, that's what this means. Which is, yeah.
One square.
Yeah, like no, if there's like an infinity here, right?
Well, why is there one square in there?
Oh, you can do that too. I can do like this. This would be 2 is less than or equal to x is less than 5. Right? Okay, like I said, you don't have to use this with the textbook. Use it if you like the other way for the main range. You can use it. Also, Mr. Kemp will use this. So I'll write it on there. Here's your homework for tonight. If you don't have a textbook yet, please make sure you get one at your earliest convenience. As you can see, we did a lot of examples here. There's not a lot to what we did today. Give a shot at 16 and 17. They talk about transformations. Okay, they talk about like you have an execute near what the shifts are and all that. So give a shot at those. If you can't do them, we'll talk about them tomorrow. But there isn't a lot tonight because there wasn't much today's lesson. Okay, so if you don't mind me saying, I wanted you guys to conceptually mostly understand the idea of a cubic and a negative cubic and all that stuff. Right, that's what it is. You should be a teacher one day. You know, like, I'm not going to say it. I shouldn't say it.